Hello friends, welcome to my channel DataMaking. In this channel I create technology videos on big data technologies like Hadoop and Spark, and also I create technology videos on programming languages and machine learning and deep learning. Okay, so we were actually last few videos we were seeing the basic concepts of HDFS, which is a Hadoop distributed file system. Okay, so we saw the what is HDFS and what is the benefits we can get from HDFS, and also how to work with HDFS. Okay, so we took last video like to practice or connect to the HDFS using the HDFS command line client. Okay, to further to that, okay, so when you use copy to local, right, when you use copy to local, what happens is the file from HDFS, okay, comes from HDFS to the local system, which is the copy to local command. So that is a read operation. So you are reading some file from the HDFS. Okay, we'll understand how it internally works. Okay, so then in the next video we'll see how the copy from local. Okay, copy from local. What happens is from local, it is the data is or file is written to the HDFS. So we'll see how that is happening. Okay, so before going to the topic, I would request people to subscribe my channel and click on bell button to get notification whenever I add new videos. Thank you so much people who are already supporting my channel. Okay, so let's jump onto the channel. So jump onto the content video. Okay, so minimize the recording window. Now, so we'll see how the write operation flow works in HDFS. Okay, so before starting into that write operation, how write operation works in HDFS, we'll try to understand two main thing in Hadoop cluster. Okay, so Hadoop cluster has two type of nodes. One is a master node, another is a slave node. Okay, so master node contains a name node. Okay, so name node are also called master node. Okay, so where you have a data nodes is called slave nodes. Okay, what name node is going to hold is going to hold the metadata about your files and directories and block location. Okay, so that is information it is going to have it. So when I say metadata, it is going to have the file location or directory location and what are the permission is set to that files and folders, those information, when it is created, when it is modified, those information, and also it is going to have the block information. Okay, so when I say whenever we I told you whenever we load a file to the HDFS, the data will be split into fixed sized blocks. Okay, so that blocks are actually stored in the data node. Okay, only the block information, the name node will have only the block information, the actual data or the blocks are stored in the data node. Okay, that you need to understand this in this slide. Okay, basically we have two type of nodes. One is the name node, another one is the data node. Okay, the name node will have metadata information about your files in HDFS, and the data node will have actual blocks. Okay, so understand this. Now we'll go to the how the read operation happens. So example, so now what we did is in the last class, so we try to run the command which is the local copy to local. Okay, so what we given, we actually try to get the file called transaction details.txt. okay, when you want to get that file, so what happens is, so when you run this client, command line client, behind the scene there will be a Java program which will get executed, because the API client, HDFS API client are in actually Java programs. Okay, so on top of that actually we have a script, the shell script actually to run that and get the information. That's why we are actually running as a command line the Hadoop commands. Okay, Hadoop FS commands, but that Hadoop FS commands internally calls the Java program, which actually does series of operation to get your file from HDFS. So what happens is, whenever you request a particular file, it goes contact to the name node, okay, and gets the block information. So each file will have the each file is already converted or the splitted into the different blocks, right? So it gets the block information. So when it actually goes and gets the block information, so what happens is name node gives, say example, you have a file which is of 3 blocks. Okay, so it gives if the replication factor is 3, okay, it will have 3 copies. So I hope I have introduced the replication factor. So basically replication factor is the one which actually decides how many copy of a block you will have it in your cluster. Okay, so you can have by default 3, you can have it less or more. Generally people will have the replication factor as 3. Okay, so it will give you for each block, it will give you the another copy of the block information also. So it will give you, say example, block 1. Okay, it will give where the block will be stored on 3 nodes, right? It will give 3 node information. So what does the client does is, so the Java program, it gets the block information, it goes and it has to connect one block, right? So we have 3 copy, say totally we have 3 blocks, and each will have 3 copies, right? So you will have 9 block information. So it has to get one block for each block, it has to get one copy, right? So it goes and actually gets the nearest data node, okay, where the one particular copy is stored. Okay, so the client will know how it will know the nearest data node. So basically all the data nodes will be actually stored or formed or arranged in racks, something called rack. A rack basically will have a set of data nodes or the nodes in your Hadoop cluster. Okay, so nearest data node, it will go and try to read the particular particular block information. Okay, so similarly, once that block is read, so another so we need to read 3 more blocks. Okay, so it goes on the second block. Say here we have a block which ending with 732, block ID ending with 590, and a block ID ending with 209. So all these 3 blocks it gets, and it constructs the file. Okay, once it constructs the file, the Java program will return the file to your local drive. Okay, that's how the read operation performs. Okay, so what happens? The client will go and request the block information. The name node will give the particular files block information. Again the client will go and read the block information from the respective data nodes. This how then it will construct and give you the whole file to the client. This is how the read operation is happening in the Hadoop cluster. Okay, apart from name node and data node, we have also have another node called another type of node called the secondary name node. Why the secondary name node is actually in any Hadoop cluster there will be a one active name node in your cluster. Okay, so there is a possibility of failure in the name node, right? So the name node can, like data node also can, there will be failure on data nodes. But if one data node fails, the copy from block, other copy of the blocks will be taken from the other data nodes. What happens if the name node itself goes down? So we need to have a recovery mechanism. So there are different type of recovery mechanism. One is you can have a multiple name node. Always one name node will be active and the other will be a standby or passive mode. So if something issue with the particular active name node, the standby name node will become active name node. Or other option will be you can have a secondary name node. The secondary name node job is to take the periodic copy of the name node and have it in the secondary name node. So whenever the name node goes down, you can actually recover from the secondary name node. This is how the Hadoop architecture, Hadoop cluster works in terms of storage point of view. Okay, so computation point of view, we'll actually understand in more detail in the when you will read about the MapReduce framework. Okay, thank you so much, friends. So in the next video, we'll see how the write operation works. Okay, so please subscribe to my channel to get more technology videos. Thank you so much, friends.